Hi guys, welcome back. So today I've got another tutorial where we're going to be using Three.js to create this cool kind of futuristic glowing cube effect. You can see we've got this cool looking grid here, and when we move our mouse we get this nice kind of bloom glow effect applied. Looks pretty futuristic, I think. You can adjust the kind of spacing of this, so if you wanted like a kind of small cube, we can come up here for example, just adjust the spacing. And yeah, it looks quite futuristic for a hero section. We can also just adjust the colours of the cube as well. So if you wanted, like, for example, a green kind of glow, we can just specify the RGB here and we get that kind of cool glowing effect. But yeah, I think it's a good tutorial just to get used to Three.js and spacing like kind of nodes in a geometry, in a cube, in a grid layout. But yeah, hope you enjoy guys, and let's get going. Thanks. Okay guys, so to get started with this project, you can see I've just got a new kind of project folder set up here in VS Code, and we're going to be using Vite to kind of run this. So this is like basically just a front end build tool we can use, and this will allow us to use like Three.js in our project and import modules like a lot easier. I find this a lot more easier than just using the CDN, so we're using just Vite for this. So if you come to the vite.dev/guide, you'll see we have this this command we can run in our terminal here just to establish or initiate a Vite project. So we can come to our VS Code here. I'll open up a terminal, and in your project directory we'll just say npm create Vite at latest, and we'll just say cube here. I'll use vanilla JavaScript for this tutorial, and then all we have to do now is we have to cd, so we'll cd into cube from here, and then we'll just run npm install like it says here, and that will just install the dependencies, and then we can just do npm run dev, and then that spins up a localhost template for us. You can see we have this kind of initial Vite app here. Now what we want to do here, obviously we don't want all of this stuff, so we can go in and delete, just like gut this out basically. So I'm just going to come to our source, we'll remove this counter.js file, we don't need that. We'll remove this svg, in the style.css we'll remove all the CSS, and then we'll also just remove everything from the JavaScript file except for the CSS import at the top. Okay, and that's pretty much it. So we're ready to get going. The first thing I'm going to do is just come into our style.css, and we're just going to do some just standard CSS. We'll just say margin 0, padding 0, and we'll just do a box sizing of border box like so. And then in the body we'll just do a background of 161616 to that nice dark grey colour, and then we'll just you'd say canvas, and we'll just say display block like so. Okay, there's no canvas yet in our index.html, but we will be injecting that with Three.js. So that brings us on to the next part. We're just going to open up that terminal again, and we're just going to now install Three.js. So to do that, we're just type in npm install free like so, and that will install Three.js. Okay, it's now in our package.json. You can see that we should have. Let's come out of that. Why is it not showing up? Let me just try that one more time. npm install free. Why is it not showing free in here? It's a bit weird. Just make sure we are in. Okay, we need cd into cube, sorry. And then we do ls. Okay, now we do it. Oh, not run dev. npm if3. Sorry about this, guys. Okay, so now in our package.json now, we should have our 3. Okay, so there it is. Yeah, so make sure you're in the right directory. Okay, and then the next thing I want to do here, so we're now just going to come to our main.js file. And here we can just say, well, we want to first just import Three.js. Okay, so we're just going to say import all as free from free, like so. So now if we come to our console, and if we just console.log free in here, we should see the module has been imported. Yeah, and then we can access all of the free functions. That's working. Okay, so that's cool. It's a bit smaller. Now, the first we need to do with a Three.js scene, Three.js is create a scene, a camera, and a renderer. Okay, so we'll just we'll create a scene, camera, and renderer setup. Okay, and then so the first one we do is create a scene. So we say const scene equals new free dot scene, and this is just where we'll be adding our objects onto this scene. Okay, and then we're going to create a camera next. We'll say camera equals new, and we're going to use the perspective camera that comes with free here. For the field of view, we'll just say 75 degrees. That gives us enough room to add our objects to. For the aspect ratio, we're just going to say window.innerWidth divided by window.innerHeight. That will give us the aspect ratio of our screen. Okay, and then after this, it wants a near number. So here we'll just do as close as possible. We'll say 0.1, and a far number will just be 1000. Okay, and then we want to set the camera position after this. We just want to move it back to view the scene, so we can just say camera.position .z, and that's going to equal 12. Okay, and then underneath here, we'll next create a renderer. We'll say const renderer equals new free .webgl renderer, like so. And we're just going to add some options in here as well. The first one will be anti-alias. We'll set that to true. And what this will do is just basically smooth out all of our edges. If you don't sometimes put this, some of your straight lines in your animation can look kind of jagged, but this anti-alias just smooths that out for us. And then we'll also just specify the alpha as true. And this means that the background or the canvas will be transparent, so we can see kind of anything in the background. It won't make the screen black. Okay, and then next thing I want to do here is just say renderer.set pixel ratio. And here we're just going to do window.device pixel ratio. Okay, so that will basically just, if I, for example, console.log window.device pixel ratio, you'll see that I get number 1 because I'm on kind of a budget screen here. It's not like a retina display or anything. If you're like an Apple retina display, this will usually be 2. I think you can even get like up to 4 some of these displays. So yeah, we're just going to be making sure that we're setting our renderer to match the device pixel ratio of the screen we're using. Okay, so that will just make sure that our animations are nice and crisp and clear. So now that we've set that, we can now just append this to the body. So we can say document.body.append child, and we'll just append the renderer .dom element, which is the canvas. So now if we come to our elements, you should see that we have our canvas displayed. Okay, so that's looking good. Now the next thing we want to do here is we just want to actually set the size of this as well. So I'm just going to say renderer.set size, and for the width we'll just say window.innerWidth, and for the height we'll say window.innerHeight. So now if we come back here, let's see, if we come back here and if we go to body, why is that not coming up anymore? Document.body.append child, renderer.dom element. Okay, so now you'll see that our canvas it takes up the full viewport. Okay, that's good. Now underneath here, next thing I want to do is let's now basically set up our cube. Okay, so for our kind of cube, we'll just say, first we're just going to define a 3D grid for structuring our kind of cube node placements. Okay, so what we want to do first is specify the number of nodes per each axis, so the X, Y, and Z axis. So we just say const grid size, that's going to equal 15. And then we'll just do a spacing variable as well. So we'll say const spacing equals 0.4 for now. And this will basically just be the distance between each of our nodes in our kind of grid or our cube. And then the next one to do now is just create the points or create the nodes for our cube. So we just say const node geometry, like so. And it's just going to equal new free.buffer geometry we're going to be using here. And then we also just want to specify a node material. So say const node material. That's going to equal new free.points material, like so. And it's going to take in an object or the parameters, and we'll specify the color. And the color we're going to be using is black for these nodes. So we'll just say 0x000000. That's like the hexadecimal code for black. And then we'll just say size of 0.05. So we want really small kind of nodes for this cube. Okay, and then the next thing we want to do here is we're just going to create a positions array. So we'll say const positions, and this is just going to equal an empty array. And what this is going to do, this is going to basically store the X, the Y, and the Z positions for each node. So just to put out, stores X, Y, and Z positions for each node. And then we also want a const nodes, and that's going to equal an empty array as well. And this kind of is going to store object versions of those nodes just so we can reference these when we want to connect them with our lines. Okay, so just going to say, yeah, stores node objects for reference used to connect the lines. Okay, and then next we want to do here is now we're just going to generate this grid structure of nodes. So we're going to need to do like 4 or 3 for loops. So so it's for loop with 2 nested for loops here. Okay, so one for the x-axis, one for the y-axis, and one for the z-axis. So to do that, we're just going to say for let y equals minus grid size divided by 2. And then we're just going to say whilst, sorry, that should be x, not y. We're going to say whilst x is less than grid size, so positive grid size divided by 2, we'll say x plus plus, like so. And then we kind of want to just do the same thing for the x and y axis here. So I'm just going to come in here, copy that down, and we just change x to y. So y plus plus, and we'll just do the same thing for the z axis as well. So just say z. And the reason we're starting off at minus grid size divided by 2 is because we want to say minus because we want to basically space this grid around the middle, which is 0, 0, 0 coordinates. Okay. So we need to do minus just to make our kind of cube centered. And that's why we're starting from a minus position. Okay, and then now what I want to do is we are just going to say, in this nested for loop, we're going to calculate the node positions in 3D space. Okay, for each node, we want to calculate an X position, a Y position, and a Z position. So we can just say here, const pos X equals, and we'll just say X times spacing, like so. We'll do the same thing for y, pos y, and that's going to equal y times spacing, and pos z, and that's going to obviously equal z times spacing. Okay, so now that we have our three spaces, or our 3 points, we now need to store these positions in a flat array for our buffer geometry. Okay, so yeah, we need to store this in. Basically, this is going to be the positions array that we're using here. So to store these x and y positions for each node, so to do that, we can just say positions dot push, and we just want to push the pos x, want to push the pos y, and the pos z. Okay, so now if we just console.log positions. We should have we've got a very large array here now, so 10,000 positions in there, and this is just what Three.js is going to use to position each of our elements, okay? So now the next thing we want to do here is we also just want to store, well, you remember we're using this nodes object as well. We need this to kind of connect our nodes via lines later in the code. So here we can just say nodes.push, and here we're just going to push these elements in an object. So we'll just say x, and that will be pos x, and then we'll say y, pos y, and then we'll say z, pos z. Okay, so now if we console.log nodes, so console, and now you can see that we have a smaller array here. So we basically just have 3,375 kind of node objects in here. Okay, so now the next thing we want to do is we are going to say, now we just want to assign the position data to our buffer geometry, okay? So to our kind of node geometry. So let's just comment that, say assign the position data to buffer geometry, or our node geometry. Okay, so to do this, we'll just say node geometry dot set attribute, and we're going to set the position attribute for each of our kind of node geometries. And here we're just going to say new free dot float, let's say float buffer attribute here, and that'll be a float 32 buffer attribute. And here we're just going to say positions, so we're going to use this positions array here, the x, y, and z, and then we need to specify how many kind of points there are per position. Remember, we have an x, a y, and a z, so to do that we'll just say 3 here, okay? And that will allow our kind of position attribute to reference these x, y, and z positions, because we're referencing this positions array, and we're specifying 3 to reference the x, y, and z. Each position basically has an x, y, and z point of reference. Okay, and then now what we need to do is just create a points object and add it to the scene. Okay, so to do this, we just want to say here const node points equals new free dot points, like so. And here we can just say, want to pass in the node geometry, so we'll say node geometry here, and then we'll just say the material as well, so the node material, okay? And then we can just say here scene dot add, and we want to add node points, like so. Okay, and then the next thing we want to do now is just create connections, or lines rather. So to do that, we're just going to say, let's just comment this, create connections or lines. Okay, and then to do that, we're just going to say const line geometry. And that's just going to equal, and again, we're going to use new free dot buffer geometry, like so. And then again, we're going to say const line positions. We'll say const line positions equals an empty array. And then we'll also just say const line colors, and that's going to equal an empty array as well. And then in here, we're just going to do basically another, a nested for loop again. So to do this, we'll just say for let I equals 0, whilst I is less than nodes dot length. We want to loop through each of our kind of node object array here. Okay, so looping for each of our nodes, and then we're going to connect them, well, randomly connect them. And then we also just want to do a for, and we'll say let j equals, and we'll do I plus 1 here. And then we'll just say whilst j is less than nodes.length as well. And then we'll just say j plus plus. That should be a semicolon, like so. And then in here, what we're going to do is we're going to calculate the distance between two node elements, okay? So we'll just say const dist for distance. And here we can use the math.hypotenuse function, okay? So this is like basically just used to calculate the distance between two nodes. So what we can do here is we'll just say hypot, and we can just, we'll add in like multiple values here. So we just say nodes I, so referencing the nodes I dot x reference, and then we can say minus nodes j dot x, and then we just want to do this for the x and y axis as well. So if we just do this, we'll make this y, and then this one will make z. Remove that comma there. And then what we want to do after this is this will give us the distance. Okay, so now if I just console.log this, so console.log, we'll just say dist. You get quite a lot of console logs here. Okay, doesn't seem to be liking that. I feel like I may have gone wrong here somewhere. Yeah, nose.length. Let's try that again. So if we just do terminal, new terminal, do npm run dev. It says cd into cube, and then npm run dev. All right, let's try that again. We'll just console.log the dist. Okay, yeah, so you can see we basically just have like all of the distances for each node logged out here. Okay, and then what we can do with this kind of dist is we can say here, only connect nearby nodes. Okay, so we'll just say, so we can say here if dist is less than spacing, so our spacing we set at the top times 2.5, if it's less than that, and then we just want to specify a randomness as this as well. We'll just say math.random is greater than 0.8. Then what we can say here is line positions, that should be positions, line positions dot push, and then we'll just push nodes I dot x, and we'll do this for each position. So we'll say nodes I dot y and nodes I dot z, and then we just need to copy this as well to get the j elements as well. And then we'll just say change these to j, like so. Move that final comma there. And then we just want to create some black to white lines, okay? So we just say line colors dot push, and we want our lines to start off as black and then finish as white. So to do that, we can just say 0, 0, 0 for black, and then 1, 1, 1 for white, and that will give us our kind of lines a two-tone color. Okay, so that's it for that. Now the next thing we want to do here is now we just need to assign the line positions and color to a buffer geometry. Okay, so we're using another buffer geometry again. So what we can do here is we'll say const line material that's going to equal new free dot line basic material, and here we're just going to say we want to specify vertex colors here as true. We want to say transparent as true as well, and then we're also just going to say opacity of 0.5. Okay, to make them slightly transparent, and that transparent true just allows us to apply that opacity to our lines. Okay, let's just zoom out a bit, and then we'll also just say here const line segments. That's going to equal new free dot line segments, like so. And here we'll just say we'll pass in the line geometry and the line material. Okay, so we have that, and now the next thing we want to do is, what do we want to say here now? And then we can just do scene.add line segments, scene.add line segments. Okay. Why is this not working now? Okay, it's got camera at the Z position. I think if we do that, should be math.random down here. Let's blow up my code a little bit, so let's just run that again. Okay, so now the next thing I want to do here, we just need to render this now. So now we can just say yeah, let's do renderer dot render, and then we'll just do the scene and the camera, pass the camera in. Okay, so I think you probably can't really see that too well, but you can see that we do have our kind of segments now added. Let's just see if we've got any other errors on here. Okay. Math.random. We've gone wrong here somewhere. Just trying to figure out, guys. Sorry. Line basic material. We need to set our line geometries as well. Okay, so let's do that now. Yeah, remember we created our kind of line geometry up here. So to do this, what we need to say here is line geometry dot set attribute. Want to set our position, and here we'll just say new free dot float 32 buffer attribute, and here we'll just specify line positions and again 3 for the X, Y, and Z. And then we'll also just say here, you want to set the color as well. Line geometry dot set color dot set attribute color. And here we'll just say new 3 dot again float 32 buffer attribute, and here we'll just say line colors, and then again we'll say 3 as well. Okay, so now you can see there's our cube rendered. I think that looks pretty cool. And what you can do here is you can just adjust this math.random function here to have kind of less connected lines if you want. You can see if we do a 0.9 it goes down, if we do a 0.99 it really starts to thin out. So now what we want to do here is let's just create an animation loop. Okay, so we can say here we'll do a function animate, and we'll pass this render in here, and then we'll call the animate function. And then what I want to do here is we'll just say want to request an animation frame in here, so we'll just say request animation frame animate at the bottom, so it keeps recursively calling itself. And then what we're going to say here is we want to kind of just rotate this. So what we can do, we can just say in our animate function, we can just say, let's do this. So we'll say node points dot rotation dot y, and here we can just say plus equals 0.01. Okay, so now you can see that we're getting our kind of our nodes rotated. So let's do the same thing for our line segments. So line segments dot rotation dot y plus equals 0.01 as well. Okay, so now you can see we get that nice kind of rotated effect. Again, you can do the same thing for the X as well. Let's change these to X. Okay, and I just want to add more segments in here, so I'm going to come back up to that random random element. So if we just do random, where is it? I'll change this just to 0.9, and I think that that gives us quite a cool grid effect there. Looks pretty cool, I think. And then so what I also want to do here is I'm going to make this go with the mouse move. Okay, so to do that, what we're going to say here, I'm going to do let mouse equal, and we'll just say x of 0, y of 0, target x of 0, and target y of 0. And then we can say here window dot add event listener. I want to listen out for a mouse move, and here we'll just pass in the event. And what we can say here is we'll say mouse dot target x equals e dot client x, and mouse dot target y equals e dot client y. And then what we can say here, we also just want to do a lerp function as well, a linear interpolation function. We'll just say function lerp, and that takes in a start, an end, and a time. And we can just say return start times 1 minus t plus end times t. And this will allow us now to use, like basically animate this with our mouse move. So we can just say here, in our animation frame, I'm going to delete all this. I don't want this to rotate anymore on its own. But we can just say mouse.x equals lerp, and we'll just say mouse.x for the starting position, mouse.targetx for the end position, and we'll just say 0.05 for the timing or the interpolation timing. Do the same thing for the y. Just change mouse y to target, and it changes to target y. And then what we can say here is, we'll just say node points dot rotation dot y equals mouse dot y, or mouse, let's do mouse dot x because I think it's inverted. And then we'll do y, and then we'll do line segments. And then also let's just say dot x here, x, and then we'll just change this to y and mouse y. And now this should, okay, and then we also just need okay, that's a bit too much. So what we want to do here is, I'm actually just going to say in our kind of mouse move event, I'm just going to say e.clientx, and then here we can just say minus window.innerWidth divided by 2, and then we can say here we can times this by a 0.01, and we can do the same thing here as well, client y, and we'll just say minus window dot inner height divided by 2, and again we'll just times this by a 0.1 just to make that effect less harsh. Okay, so now you can see that the cube is following my mouse move around, and we get a nice kind of linear interpolation going ahead. Okay, so that's looking pretty cool, I think. Obviously, we need to adjust for a screen size change as well, because it's not adjusting to be the center of our screen. So to do that, we can just come down the bottom here. I'll say window.addEventListener. We'll listen out for a resize event, and then we can just say we want to say renderer.setSize window.innerWidth, and then window.innerHeight, and then we want to say camera dot aspect. We need to change the aspect ratio to fit our screen, and then we can just say window.innerWidth, innerWidth divided by window.innerHeight, and then we just want to say camera.update projection matrix, camera.update projection matrix, like so. So now when we adjust our screen size, you can see that's now adjusted. Okay, so I think that, that's looking pretty cool actually, quite like that. If you want to change obviously the colors, you can also just come up here as well. For example, if you just wanted red connectors here. So this is basically like RGB, okay, so RGB for the first half. Again, if you wanted all red lines, that's what that does, okay. But we've got 2 colors per line here. So if you wanted, for example, a purple line or a magenta, red into magenta, you kind of get that nice cool effect. Okay, but I like the kind of black and white effect for this. So we just do black and white. And then I just want to also just add something really cool to this as well. We're going to add some kind of post-processing to this. So to do that, if we come up to the top here, we can just say import effect composer. Okay, and then from, and we'll just say here free / add-ons / post-processing / effect composer. I also just want to import a render pass here, so say render pass, and that's going to be imported from free / add-ons again / post-processing / render pass. And then I also just want to add a bloom pass here, so just say import Unreal bloom pass. Okay, and we're going to import that from free / add-ons again post-processing / Unreal bloom pass. And finally, we also just want to import an output pass as well. So this is basically just like, these are like final effects we can add to our whole kind of animation. So I'm just going to say here output pass. And here, yeah, we'll just say output, like so. And now what we want to do here is we're just going to say, so after this, after we've appended our child, we can just say, const composer equals new free, new effect composer, like so. And this, we pass in our renderer here. Okay, so our renderer that we created. And then what we want to do now is we're also just going to say const render pass equals new render pass, and that will take in our scene and then our camera as well. Okay, and then we can just say composer dot add pass. We want to pass in that render pass, and then we're going to add a bloom past this, which kind of illuminates our cube. Okay, so we can say const bloom pass equals new Unreal bloom pass, like so. And then we'll just say composer dot add pass, and we want to just chuck in that bloom pass. Okay, and then what we can say here is bloom pass, and we can set some parameters here. I'm just going to specify a radius here, and that's just going to equal 0.3, which gives a moderate spread of kind of bloom glow effect. And then we can also just apply a threshold here, so bloom pass dot threshold, that's going to equal 0.4 as well, and it should be 0.3. So the threshold, just again, it specifies how much of a kind of glow you'll get on this. And then we also just need to come under here, we'll say const output pass equals new output pass. This is just for the final output, and we can just add that to our composer. Dot add pass output pass, and that should just be a lowercase 0. Okay, now what we want to do, just to make this working, it's not working at the moment, you'll see, but what we want to do here, if we come back down to our animate function, we just need to adjust the renderer here, so we can just say, instead of renderer.render, we just want to say composer dot render. Okay, and now you can see that we've got it looks pretty cool, I think, a nice kind of illuminated cube. Now I want to adjust this so it kind of it glows with our mouse movement. So to do that, what we can say here is bloom pass dot strength, and that's going to equal, and we're going to use the math.abs function here, so the absolutes to get the whole number. And here we can just say mouse dot target x minus mouse dot x, and then we can just times that by a small number, 0.3 for example. So now, why is that? Oh, minus. Now you can see we get that kind of initial glow when we move our mouse, which looks pretty cool, I think. And you can obviously, yeah, you can adjust the threshold of this to bring the glow down as well. If don't like, if that's too much for you, then you can just say, for example, let's just adjust the threshold to 0.7. Oh, no, that's spacing I adjusted there. That should be 0.4. If we adjust the the threshold here to 0.8, for example, yeah, you get less of a glow, but you still get a slight glow. But yeah, adjust that to your taste, really. I like the 0.4. And yeah, you can just, tweak these how you want, really. But I think that's looks like quite a cool effect when you get that kind of glow and the grids. And obviously, if we change the color as well again, now you can see we get that kind of nice green glow. Yeah, it looks quite futuristic and cool. But I'm going to leave this video there, guys, because it's getting a bit long now. But yeah, I hope you enjoyed the tutorial. This one looks good, good for like a landing page or a hero background. If you have some text over it. And yeah, it looks pretty smart, I think. But yeah, I hope you enjoyed that. Also, I just want to try playing around with, let's see if we can add more segments in here. I'm conscious I don't want to blow up my processor, but if we, for example, just say, I don't know, 0.6. Oh. You can see we get a lot more segments now. Let's change this to 0 again. You can see now we've got a lot more segments there. Actually, that's probably too much if we go for 0.8. Yeah, okay, cool. Yeah, thanks for watching, guys, and I'll see you in the next tutorial. Thanks.